Welcome back to another rousing video of AP Precalculus nerds. Today we're going to be tackling section 1.7, and it is the end of the chapter actually, so this is it. Okay, the last section. The last section is called modeling with functions, so we're going to finally use this mathematics in real-world settings. That's not to say that every time I do it, that's something that you would actually do in the real world. Realize that authors and me, when we have to make a word problem and stuff like that, we're doing our best to write a story to go along with the mathematics, okay? This first question, any of you that have already taken chemistry, you're familiar with questions like this. Dimensional analysis, I think that's what it's called in chemistry. It's unit conversion. Let's be real. It's unit conversion, okay? This first question says, how many rotations does a 15-inch radius tire make per second? So rotations per second when an SUV is traveling 70 miles per hour. We are literally trying to convert between miles per hour and rotations per second. I'm going to call them rots per second, okay? What we have is 70 miles per hour. Did you know that the per in miles per hour is a fraction bar? It means divide by. So we're going to take our 70 miles, MI, per 1 hour, and we're trying to convert all the way over to rotations per second. Just so you know, when you go to do your homework, there's only one example like this, and it's actually towards the end of the homework assignment, and I didn't have the time, honestly, to reorder the homework assignment like I've done in the past. Just realize that if you try to start your homework tonight, you'll have to go towards the end of the assignment to track down the one question. It's like a saw blade in a sawmill or something. You're trying to talk about how many teeth per second hit the wood, and it gives you revolutions per minute or something like that. Yes, sir? No, they do it in chemistry also. So is it done in physics as well? Dimensional analysis? Okay. Oh, so they do it in both. Cool. Yeah. Chemistry, you end up doing like moles per gram and things like that. So it happens in chemistry also. Yeah, who doesn't hate chemistry, right? Okay. You be quiet. So 70 miles per hour. Tell you what, we have a distance per time, and we are trying to get to rotations per second. And believe it or not, we're going to have to try to figure out a way to make rotations a distance, because this is a distance and this is a time. Well, this is a time, which is pretty easy to convert from hours to seconds. It's pretty easy. So let's start there. What do you know about 1 hour? What does it have in it that you instantly know? 60 minutes. We know there are 60 minutes in 1 hour. So what I'm trying to do now is I'm trying to convert away from hours. I need to be able to cancel hours. So since hours is in the bottom of the first fraction, I got to put hours in the top of the next fraction. 1 hour is 60 seconds, and I have canceled hours. Minutes is what I meant to say. Minutes. Guess what we're going to next? Seconds. So I was thinking ahead. So right now what we have is a miles per minute. That's what we have now, miles per minute. I'm not going to actually do the division or multiplication right now. We're just reading the units that we have left. We have miles per minute. And we can easily convert our minutes to seconds. How many seconds are in a minute? 60, and I was thinking ahead. So since I'm trying to cancel minutes now, I need minutes in the top of the next fraction. 1 minute is 60 seconds. I can cross off this tiny minutes that I wrote right there. And again, I'm not doing any multiplication right now. Just the units that I have left. I have miles per second. So we've got part of this fraction done. We've got the per second. We now need to convert miles, a distance, to rotations. At this point, you know what we're going to do? We're going to kind of work backwards a little bit. We know towards the end we're going to get rotations. That's the idea. The very last fraction is going to have rotations in it. And the rotations is my distance. So what I need to do right now, just to think ahead, is I need to be able to convert my rotations to a distance, when all I know about my tire is that it has a radius of 15 inches. So how do I convert a single rotation to a distance, Adi? Find the circumference. Boom, there it is. The circumference of a circle is a distance. So let me remind you, circumference is 2 pi r. Our circumference then is 2 pi times 15 inches. This is AP, so we have to use units. That's, don't you touch that calculator yet, 30 pi inches. A circumference is going to be one rotation. So we now know the length, the distance of a single rotation. Oh, it's in inches. Okay, that means I need to convert my miles to inches. Does anybody know a unit of measure for miles? Okay, Mark? 5,280, what? What is he? Feet. There we go. 5,280 feet. I'm looking for a unit. This is AP. So there are 5,280 feet per 1 mile. And the reason why I put miles on the bottom is because it was on the top. So I have to, something that's in the top gets canceled by putting it in the bottom. My miles are canceled like that. Quick question for you. I don't need an answer. I'm just posing it to you. Why 5,280 feet? I don't want answers. Just think about it. Why? I don't know if there's an answer. Okay, anyway. Hey, check it out. Shh. Okay, here we go. Before it gets too political, I'm pausing this. That was fun. So, 5,280 feet. We now have feet per second. We need to turn our feet into something that we could use. Oh, that's right. Oh, my paper's crooked. We're trying to get to inches. We've already said this when the video was paused, but they're how many inches in a foot? 12 inches in 1 foot. So we put the 1 foot in the bottom of the fraction. That way I can cancel my feet. I have 12 inches on top. The inches, feet now cancel. Units. I now have inches per second. I'm almost there. Luckily, I know that 1 rotation is 30 pi inches, which means I can cancel my inches by putting 30 pi inches in the bottom of the next fraction. Last fraction, say 1 rotation is 30 pi inches. And at long last, purple comes in, crosses out inches, and my units that are left are rotations per second. We've done it. Congratulations, you done it. Here's how we're going to get the answer, though. We're going to grab our graphing calculator. Because our graphing calculator has the ability to do stacked fractions. Stacked fraction shortcut is alpha, y equals, and then we hit enter. Boom. So on the top, I'm going to type 70 times 5280 times 12. Press the down arrow. On the bottom, I'm going to type 60 times 60 times 30 pi. 30. And on this graphing calculator, the pi button está aquí, right here above the caret. So second caret puts a pi next to my 30, and I hit enter, and it's just a little bit more than 13 rotations per second. This is AP, which means I screwed it up in second period and forgot. I need to round to 3 decimals. AP is 3 decimals. So 13.072, and it is AP, so we better use our units. Rotations per second. There it is. If you what? I don't know, they wouldn't care. But it's because we typically don't say rotations, we typically say revolutions. And R, but the problem is R could also be used for radius. So I would just, would it kill you to write rev or rot? Mathematicians might. Anyway, Mark, what's up?
Whenever I see like an answer like this, like for example, in a book, it always has a rounded.
Oh, you mean the squiggle equal? It won't matter because AP is telling us round to 3 decimals. So they wouldn't be picky like that. Okay, yes, ma'am? Your calculator's not turning on.
It was working last night, but yesterday I was doing homework.
Well, that tells me that the batteries are probably dead.
Damn, that quick. They're new batteries.
Are they?
Yeah. You might have picked them up from the store. Like,
They're Publix brand batteries.
yeah, they can't be that bad.
Well, I don't know about all that. Oh, this is in the video. I should have paused the video. Repaired. Back to it. Calculator repaired. Okay, next. In these 3 examples, we are writing functions in terms of different kinds of variables. The first one, though, it's not bad. We're being told, write the area of a circle, and then it's telling us what to use as the variable. The first one says the radius. And the reason why that's not bad is because we're used to using the radius to find the area. Area of a circle is, who remembers? It is. How can it be 2 pi r when I just told you circumference was 2 pi r? Pi r squared. Now, let's talk about it. For students that have trouble remembering which one is which, what is the exponent on r here? 1. It's one-dimensional, like a straight line. However, areas are often described using squared units, right? Like square feet. That's how you can remember which one is area and which one is circumference. Yes, ma'am. Sphere is 4/3 pi r cubed because it's the 3rd dimension. You might be wondering why the 4/3, right?
Not really.
Oh, you're not. Well, then
I'll listen.
I'm not going to tell you.
Oh, I want to know.
The answer is calculus. That's the quick answer. Next, now that we know what the area of a circle is when we use radius as our variable, let's go nuts. And instead of using radius, let's use diameter. But how am I going to do that? What do we know about the diameter? Ah, it's 2 times the radius. Yes, yes, yes. The diameter is 2r. Hey, it's just compositions of functions again. Solve for r. Get r alone. R equals diameter divided by 2. Which means you could replace this r with this r. Where I used to have an r, I'm going to open a set of parentheses, and I'll replace it with d over 2. I do need you to realize that this pi is pi over 1. So when I multiply these 2 things together, this pi goes to the top of the fraction. Anyway, you know, I'll go ahead and go back to pink. Area is pi in the top of the fraction, d squared over 2 squared. There. So if ever someone said, here's the diameter of a circle, what's its radius? You could divide by 2 and use pi r squared. Or you could be super extra and use a formula that you'll never remember. But the point is, you could. You could. So much in mathematics is someone's like, why? And you go, because you could. That's why. Like this last one. Circumference of a circle. If given the circumference of a circle, do I instantly have a formula that I could plug circumference into and get the area in my mind? No, I don't. Could I find one though? Yeah. Which is what we're going to do. So what do we know about the circumference again? It's 2 pi r. So we know that the circumference is 2 pi r, and dag nabbit, there's an r there. Which means if I solve for r, I can put it right there. I'm going to divide both sides by 2 pi. So my radius is circumference over 2 pi. Like so. I'm now going to take my area formula, and where I had a radius, I'm going to put this fraction. Okay, this one's going to take more than one step. Gets me here. This pi goes on top of the fraction again because it is pi over 1 and it's being multiplied to a fraction, so it goes to the top. Pi c squared over 2 squared, 4, pi squared, which is pi squared. Well, because there's a pi on top and a pi squared on the bottom, I can reduce. This 1 pi will eliminate one of the 2 pi's that are on the bottom, leaving me with the area of a circle is circumference squared over 4 pi. Did I know that formula? Nope. And I just did it 2 periods ago and I still didn't know it. This is one of those things that I would never bother memorizing, but I could build it if I needed to. There it is. I just built it. Done. Ta-da! Yay!
Do you need to like simplify it to its most simple form?
That is its most simple form.
Yeah, I know, but like to get the right answer.
Oh, do you need to reduce the fraction, you mean?
Yeah.
Yes. If you can reduce a fraction, you need to reduce a fraction. If this was IB, then no, you wouldn't need to, but this is AP, and AP wants you to reduce your fractions. College Board, dag nabbit. Now I see what that Ron DeSantis is always complaining about.
Do you want to pause the video?
I was just, no, he hates College Board.
Oh, okay.
I was just saying. I actually don't have a problem with College Board. But just, okay, next. This next question is going to require graphing technology at the end. But before that, I have a prop I'm going to show you. It's too bad the prop isn't going to show up in the video. I know. I don't have a tiny prop is the problem.
You can see it on the camera real quick. We'll get a glimpse of it.
No, like literally the prop is way too large. It won't fit under the camera.
Under the camera?
No, it won't fit. Anyway, this is a max value problem. And anytime we're going to maximize or minimize things, and it's not in AP Calculus yet, we're going to need to use our graphing technology to do that for us. This is a square of side length x, meaning I actually don't know how large the square is being cut out of the corner, each corner of an 8 by 15 piece of cardboard. The sides are folded up to form an open top box. That's kind of difficult for students to wrap their mind around, and that's why I have this prop that I'm going to show you, which I'll just pause the video because there's no reason for you to hear me describe the prop. There. So you saw me use the box prop. Let's draw it. Because questions like this are much easier to do when you have something to look at. I'm going to draw a rectangle. Oh, where's that brown pen I just got? I do have, you know what, I don't want to wait. I don't want to waste time. I did just get a brown pen. I could have drawn this in brown because cardboard is brown. There's my rectangle. And I'm going to remove a square off of each corner with red dotted lines. There. Imagine the machine came through and cut each of those squares off. What we know is that the length of each square is x by x. X by x. We know that. And we were told that the box is 8 inches by 15 inches. So based on the way I drew it, we'll call this one 8 inches. And based on the way I drew it, we'll call this one the 15-inch side. There we go. The red squares are going to be removed and is going to give us an open top box when we fold it along these green dotted lines. You don't need to draw these in. I'm just showing you. We'll fold this flap up towards the left, this flap up and forwards, this flap up and to the right. So I'm just showing you. So these 4 rectangles are now our flaps, and that's the bottom. Kind of hard to talk about it though, right? It'll be easier if we see an open top box. So back to art school we go. I'm going to draw an open top box. You can follow along if you'd like to. The way I do it is with rectangles and parallelograms. So I draw a rectangle. Now, I'm going to put a parallelogram on top of it. So I go up and to the right, try to make them the same length, same angle, and then draw a horizontal line connecting them. Here, I have 2 sides of a parallelogram. I'm going to complete the parallelogram by taking this up and down line and draw it right here. Do the best to make it straight down in the same length, and then up and to the right again. I now have what appears to be a box. Now, I could do the question just like this, but I want to be extra, and I want to show you that it is open-topped, which means I want to be able to see inside it. The way you can do that is you can do this. You draw a line, stop. There you go. Look, I can see inside my box. Yay! I know. I should have been an art teacher. Screw all this math stuff. I'm out. It's never too late, they say. You know, everybody says that. It's a dirty liar. All right. It's way too late. By the time you're saying it's never too late, it's been too late. Now, let us find the... You know what? Why don't we look at the questions? Part A, write the volume as a function of x. Oh, I need the volume of this box. But how do we find the volume of a box? What is it? Just height? Length, width, height. Length, width, height. We need all three of those. Oh. Well, surface area is the area of each of the sides plus the area of the top and bottom. But yes, kind of. Surface area is two-dimensional, volume is three-dimensional. Anyway, let's find the length, the width, and the height, but in terms of x, because we need our volume to be in terms of x. The length, we'll say that this is the length. It doesn't matter which one you call length. We'll say this is it. This side right here is this green dotted line. So this green dotted line is this length right. But what is that? I mean, the box was 15 wide, but then a couple squares were cut out of it. So what can we write here? Do you know? 15 minus 2x will be that one. Good. And someone in the back said what this dimension is going to be. I don't want to call it the length, I guess. 8 minus 2x, because it used to be 8, but we cut those two x-sized boxes out of it. So 8 minus 2x. Then how tall is the box? X, because this right here is when these two red lines become 1 when we fold it up. So our volume is actually, order of multiplication doesn't matter, x times 8 minus 2x times 15 minus 2x. That is an equation for the volume of our box in terms of x. Neat. By the way, we just completed part A. It took us that long. All right, part B. Part B says to find the domain. That's what x values are allowed. You realize that I'm talking about a real world question right now. This is a real box with real lengths. What do we know about the number x? It can't be negative, but it also can't even be 0. Because if it was 0, then we've actually not cut anything out. So what we know is that x better be bigger than 0. We know that. But there is a limiting size as well. There is a number that x cannot go above. Because again, the lengths of this thing are real. No, I just said that's not possible. It can't, so you're telling me x can't go above 8? Well, if you say x can't be bigger than 8, you don't have to say or bigger than 15, but x also can't be 8. That's way too big. X can't be bigger than 4. There it is. The smallest side of this box, the limiting side, is the shortest side of my piece of cardboard. The shortest piece of cardboard was 8, and we subtracted 2x from it. This length is not allowed to be a negative number. It's not even allowed to be 0. So what we actually had to do was say 8 minus 2x had better be a positive number. So if you add 2x to both sides and then divide by 2, you get that x is less than 4. I know that that's reading that backwards, but still, x is less than 4. So our domain is, I wrote 0 again, darn it, is the numbers from 0 to 4. Not inclusive. So if you wanted to write it in interval notation, it'd be a set of parentheses around the 0 and the 4. Part C says to graph this function using our domain, use the maximum value finder of our graphing calculator to determine the maximum volume that such a box can hold. To the technology we go. on. And we're going to go to y equals. I'm going to type this exactly the way I see it. X, parentheses, 8 minus 2x, close them up, open a new set, 15 minus 2x, close them up. I am not going to tell it to graph. Yes, sir?
How do I get out of the X1 key?
How do you get out of parametric mode? Press mode, and then come down here and highlight function, hit enter. And then go back to your y equals, and you can type it there. Okay. So here we have our equation. I'm not going to hit graph. Here's why. I have a restricted domain. This restricted domain is our window. So we go to the window. Blink. You see, the standard window goes from -10 to +10. But we've said we can only go between 0 and 4. And we might as well let the x-axis count by ones. It's going to go 0, 1, 2, 3, 4, whatever. Y minimum. What's the minimum volume? 0 is going to be the bottom volume. Negative volumes are impossible. So we go from 0. Oops. I wasn't there yet. We go from 0 up to, I have no idea. We need to put an educated guess here. Someone want to have an educated maximum volume guess? Well, I mean, the volume is 3 dimensions, though.
I know. If you plugged in 4 for the X's, that'd be the max, right?
No, because that'll be 4 times 0 times 7. 32. Why such a weird number, 32? 20? So let's type 20. I guess we can have 20 tick marks, whatever. Let's hit graph. Oh, crap. 20 wasn't high enough. You fail, dummy. Or you just go, okay, no big deal. How would you have known how big to go, right? So go to the window and go bigger than 20. Whatever. Let's try 50. I don't want to have 50 tick marks, so I'm just going to divide by 10 and count by 5s. Let's see if 50 was big enough. Graph. Crap. Still not there. All right, let's go to 100 then. 100. Again, I don't want to have a whole bunch of tick marks. I'm just going to divide by 10 and get 10 tick marks. Is that big enough? Ah, okay, pretty cool. There we go. So what we're going to do is we're going to sketch this into our notes. Here's my sketch. Picture not drawn to scale. It actually peaked towards the left and did something like that. Here's what we know. This was at 0 and this was at 4. We're trying to find the maximum volume, right? That maximum volume is going to occur here because my y-axis is my volumes. I need to track down where, let me use a different color. What haven't I used? I haven't used enough green. I'm going to track down where this point is because where it is the x that we need. What it is the maximum volume. And our calculator can find these kinds of things for us. We're asking our calculator to calculate something on its graph, which is that command right there, calc. So second, calc, and we're asking it to find a maximum, which is command 4. So you just type 4, or you can scroll down and highlight it, hit enter, whatever. I'm just type 4. Now, I only have one graph on my screen. Do yourself a favor when you're trying to do maximums and minimums. I don't know if you caught that, but you could also do minimum if you had a graph that was pointing down. Anyway, do yourself a favor, only have one graph on the screen. Like, get rid of the other ones. Anyway, you'll notice that the calculator is prompting me. Left bound? So that means, can you get me to the left of where you know the answer to be? I mean, we know the answer is right there at the top of this bump, right? We just want to know what the top of that bump is. So I'm going to go to the left and hit enter. And then it says, okay, can you please go to the right of where you know the answer is? Sure. That's to the right of where I know the answer is. Hit enter. And this says, can you take a guess? I go, yeah. Basically, just try to get close to it. That's pretty close. And hit enter for the last time. And what it's going to do now is give you the x comma y of that coordinate. This x is what size x did I want? Looks to me like 1.6 repeating was the magic x. The magic volume, though, the maximum volume is 90.741 because 3 decimals. I see your hands. Hold on. Yes? Questions?
So you went far into the lake.
You go to the left of where you know the answer is and hit enter.
Okay.
Then you go to the right of where you know the answer is, hit enter. Then just get between the 2 lines that it just created and hit enter for the last time. Okay. Yes?
It didn't create why does it make you do that? Why can't it just calculate it?
Why can't it just calculate it? What an interesting question. Here's why. The calculator,
I think I broke it.
no, you just did it wrong. The calculator is using extremely complicated upper level mathematics to do its best to estimate where that answer is. And like I could have found that answer with calculus, but we didn't program the calculators to do calculus. We programmed the calculators to do extremely accurate, remarkably difficult estimations of curves. It uses Taylor series and Maclaurin series approximations, which is something you learn about in Calc 2 if you ever take it. And it is not perfect. It is an approximation. But that's why the calculator, that's why it's saying go left, go right, go center. It's because it's not doing calculus. It's doing stuff that we know is true because of calculus, and it's crunching numbers. And you saw up here it did that little spinny thing. That's because it was crunching numbers and thinking. And the more difficult the question was, the harder it would have had to think and the longer that would have taken to do. But that's why. You're doing it wrong. Bring me your calculator. I'll pause the video while I fix her again. Anyway, the question asked us to figure out what the maximum volume was. This is the maximum volume. So the max volume, the answer for C is right there. D is the size of the box that had to be removed. So we say max volume equals 90.741 cubic inches at x equals, and you can either say 1.6 repeating inches or you could round it to 3 decimals because it is AP, 1.667. Let's just round it to 3 decimals like that. So that was the answer for C. That was the answer for D. Isn't that fun? And you do have a test question that requires you to be able to maximize on the test. Yeah.
So do you, so for the first time you went second.
So second, trace, maximum, which is command 4. And the calculator asks you to do it. You don't have to memorize it. It tells you, hey, go to the left. So you just listen to the commands on the bottom of the screen. It says go to the left of the answer, you hit enter. Go to the right of the answer, you hit enter. And then try to get close to it by taking a guess and hit enter. There it is. Yep.
Can you please show me again what you put in the y section?
Y equals? I put that.
Oh, you put that
Yeah.
3 things.
Yeah, just like that. Because this is my volume equation. Good? Okay. Questions, comments, concerns on that? Or we got it?
I think I got it.
Okay. Well,
I don't know if anything else.
let me see what's on this next page to figure out if I want to continue the video. I'm never going to be able to get the next question done. Okay, we'll call the notes there today. Wait. Thanks, nerds.